Now coming to the non-tabular forms of data presentation. So here we have many types of data presentation, and they are used commonly in our day-to-day life also. So number one is histogram. So what is this histogram? It is indicated for quantitative data of continuous type, means the data which goes on changing, like height, weight, blood pressure. It is an area diagram consisting of series of adjacent rectangles. So what we draw in this rectangles, and they are attached to each other, or they are adjacent to each other. There is no gap between two these diagrams. The area of each rectangle represents the frequency in the corresponding group or class. So one rectangle is equal to the frequency in that class or in that group. The width of all bars is equal to the class interval, and heights of the bars are proportional to the frequencies of the respective classes. All the bars are drawn continuously, adjoining to each other without any gap. So there should not be any gap in case of histogram. Like this, heights of black cherry trees. So you can see here, the height is between 60 to 65, 65 to 70, 70 to 75, likewise up to 90. And the frequency is on y-axis. So this is the typical histogram. This is another example of histogram for serum cholesterol in millimoles per liter. Now, second type is frequency polygon. So it is also an area diagram of frequency distribution developed over a histogram. Means we will use histogram for preparing the polygon. So what we are supposed to do? Join the midpoints of class intervals at the height of frequencies by straight lines. Means at the tip of the area diagram or rectangle, you have to put a point at midpoint, and then you have to join these midpoints which you have put over the rectangles at the top of the rectangles. So that will give you a straight line joining the midpoints of the rectangles. So it gives you a polygon. A frequency polygon may be chosen to compare two frequency distributions such as birth and death rates. So here you can see there is a histogram, and they have joined the midpoints of the rectangles. So you got a frequency polygon. So if you don't draw the histogram, you will get the figure like this. So here you can do the comparison between two groups also in the frequency polygon. Now next is line chart. I think many of you watch cricket matches. So whenever the score is increasing and the number of overs are getting finished, they show you the relationship between the overs and the runs. So if it is a first inning, they will show it for one team only. But if it is a second inning, they compare the second inning with the first inning. Means how many runs were there at the end of 5 overs? How many runs were there at the end of 10 overs? How many wickets were there at the end of 15 overs? Like this, you can compare between the scores of two teams. So that is the typical example of line chart. So this is again this is a frequency polygon presenting variations by line. So we put a line in this diagram. It shows the trend of an event such as rising, falling, or showing fluctuations such as cancer, infant mortality rate, etc. over a period of time. So like in one-day match, for 50 overs, we show for 50 overs. In 2020, we show for 20 overs. Like the data is shown for 1 year. So 1 year period can be taken, and you can compare between the frequency for particular variable. The class interval may be a month or year. Vertical axis may not start from 0, but at same point above when frequencies start at high level. So it can be at high level the frequency can start. The shape of line chart may alter with change of scale on the vertical or horizontal axis, but the trend indicated remains the same. So this is one of the example of the line diagram for the number of push-ups. Next is cumulative frequency diagram or Ogive. Sometimes they give short note on Ogive in your theory exam also. So Ogive is a graph of cumulative relative frequency distribution. So I will explain you what do you mean by cumulative relative frequency when we show you the diagram. So to draw this, we should convert ordinary frequency distribution table into relative cumulative frequency table. So we have seen simple distribution, frequency distribution table. So that need to be converted into the relative cumulative frequency table. And from that data, you have to prepare the Ogive. So it is obtained by cumulating the frequency of previous classes, including the class in question. So if there are 4 classes, like I have shown you for the age distribution, 3 to 5 years, there are 5 children. Then 6 to 8 years, there are 10 children. So in cumulative frequency will be 15 for group 2. And in group 3, if again there are 5 children, so the cumulative frequency will be 20, like 5 plus 10 plus 5. So that will become 20. That is called as cumulative frequency. So the cumulative frequencies are plotted corresponding to the group limits of the characteristics. On joining the points by a smooth freehand curve, the diagram made is called Ogive. It is useful in finding out quartiles, deciles, and percentiles. Now this is the diagram of Ogive. So you can see here that there are x-axis and y-axis. So what they have taken on the x-axis, that is the lower quantile, median and upper quantile. Like this, we can find out from the Ogive. So on x-axis, there is one frequency, and on y-axis, there is one frequency. So for the first red line, you see that it corresponds to the 8 and 28 number. So in this case, the frequency is 8, whereas for 30, the frequency is 16. So at the 30 point, the cumulative frequency will be 8 plus 16. So that will be 24. At 34, the cumulative frequency will be 24 plus 24, that is 48. So like this, you need to add the frequency of each class into the other class and combine them, and you get the cumulative frequency, and from that we prepare the Ogive graph. Now next is scatter or dot diagram. It is useful when the relationship between two quantitative variables is to be shown. So what they do, it shows the nature of correlation between two variables characteristics in the same person or groups, such as height and weight in men aged 22 years. Suppose you take a group of 50 people of 22 years of age, and in that you want to compare the height and weight. So you will prepare the scatter or dot diagram. So it is also called as correlation diagram. The characteristics are read on the base, that is the height on x-axis and the vertical weight on the y-axis, and the perpendiculars drawn from these readings need to give one scatter point. So direction of the line will show you what is the correlation between the two variables. So varying frequencies of the character give a number of such dots that show a scatter. A line is drawn to show the nature of correlation at a glance. So this is a typical example of this scatter graph. So here one variable is compared with the second variable, and the observations are plotted on the graph in the form of the dots, and you get a scatter dot graph. And here we draw a line. So this is a typical example of the linear correlation between the two variables. So here the variables are actual birth weight and what is the estimated birth weight for that particular age. So these two variables are compared, and it is showing a straight line, and it is in the ascending order. So there is a linear relationship between the two variables. Now last is the bar diagram. So this diagram is most commonly used, and it is indicated for qualitative data or quantitative data of discrete type, not for the continuous type of data. Base of all the bars should be of same width for qualitative data, and heights will correspond to the frequency. So we have the base or width of the bar, and also the height of the bar will indicate the frequency. Each bar corresponds to frequencies in case of quantitative data. The length of the bar will be corresponding to the class interval length of the bar, and height of the bar will be corresponding to the frequency of the observation. Spacing between any two bars should be nearly equal to half of the width of the bar. So here, in case of bar diagram, there will be a gap, or there will be a space between the two bars or two rectangles, whereas in the histogram there was no gap. There are three types of bar diagrams. Number one is simple bar diagram, number two is multiple bar diagram, and number three is the component or proportional bar diagram. So this is the example of the simple bar diagram. So here you can see that there is an equal group interval. So width of the bar will be same, and the space between two bars will be half of the width of the bar. This is called as multiple bar diagram, means two or three bars are shown adjacent to each other. So that is for comparing between the two variables. And proportional bar diagram will be shown by one bar will have different components or proportions. Like you take the example of the 100 deaths in a population, and you find that 20 deaths are by the cancer and 15 deaths are by the myocardial infarction or heart attack. So here you can show 20 deaths also, 15 deaths also, and remaining 65 deaths also in one bar diagram. So like this, we prepare the proportional bar diagram. Now coming to the pie or sector diagram. So it is indicated for qualitative and quantitative discrete type of data. The frequencies are shown in a circle. So always there will be a circle for the pie diagram. Degrees of the angle. All of you know that one circle is having total degrees of 360 degrees. So degrees of the angle subtended by each variable denotes the frequency and the area of the sector. So at the center of the circle, each observation will form an angle. So that angle will denote the frequency of that particular variable. So it gives comparative difference at the glance. Size of each angle is calculated by two methods. So you need to find out how much will be the area of a particular variable in the circle or pie diagram. So class percentage is calculated by 3.6 into the observation, number of observations, or class frequency by total observation. Suppose that we have, like I have given you example of 100 deaths in an area. So 20 are by the cancer. So 20 into 3.6, like this we have to prepare. So it will come to 18. And for 15 and for 65, like this we have to calculate. So second method, class frequency 20 divided by total observations, that is total, that's 100 into 360. Like this we'll find out the angle, and then in a circle we will prepare the different sectors in the circle. So that's why it is also called a sector diagram or pie diagram. So in this type of diagram, you will be able to compare the observations between 2, 3, or 4, 5 variables just by showing in a circle. So this is called as the pie diagram. Pictogram or picture diagram. So in this, what they do, they take the help of pictures for a particular observation. So this is indicated for qualitative and quantitative discrete type of data. It is a popular method to impress the frequency of the occurrence of events to common man, such as attacks, disease attacks, deaths, accidents, etc. in a population. It is displayed in the form of pictures. So for the common people, they prepare the pictogram or picture diagram so that people understand easily by just seeing the picture. So like this, in this diagram, they have shown that Monday number of apples sold. So you can see on Monday there are 6 apples. So here one apple means, one figure of apple means there are 2 apples. So on Monday you can see that there are 6 pictures are shown. It means that 12 apples are sold. Tuesday 3 pictures are shown. It means that 6 apples are sold. So likewise, the number of apple will indicate the number of apples sold on that particular day. Sunday you can see that there is no picture. It means that the market is closed and there is no sale of apples. So this is all about the data presentation. So please remember that where you try to understand the type of data given and what method of presentation of data you should use for a particular type of data should be kept in the mind. So like this, we need to present the data so that people can draw the conclusion from the data. So this is all about the data, types of data, and the presentation of data. Thank you.